Welcome. My name is Marcus Whisaw, and I will be your facilitator for this Hazard Communication and Global Harmonization System presentation on Appendix B, Fiscal Hazard Classifications, Part 2. This presentation will continue our survey of the 16 fiscal hazard classifications under Hazard Communication GHS, their meanings, and how they fit into hazard communication. This second part will continue on from self-reactive chemicals, where we left off, to pyrophoric liquids, where we will start the conversation. If you have any questions, my contact information is listed on the screen. Pyrophoric liquid means a liquid which, even in small quantities, is liable to ignite within 5 minutes after coming into contact with air. There is but a single category, Category 1, for pyrophoric liquids. Let's now discuss pyrophoric solids. Pyrophoric solid means a solid which, even in small quantities, is liable to ignite within 5 minutes after coming into contact with air. Again, we can note only a single category for pyrophoric solids. Let's turn our attention now to spontaneous heating chemicals. A self-heating or spontaneous heating chemical is a solid or liquid chemical other than a pyrophoric liquid or solid which, by reaction with air and without energy supply, is liable to self-heat. This chemical differs from a pyrophoric liquid or solid in that it will ignite only when in large amounts, after long periods of time, such as hours or days. There are two categories listed within the Hazard Communication GHS system pertaining to self-heating and spontaneous heating chemicals, which are Category 1 and Category 2. Category 1 self-heating or spontaneous heating chemicals are defined as those where a positive result is obtained in a test using a 25 millimeter sample cube at 140 degrees centigrade. Category 2 self-heating or spontaneous heating chemicals will have a negative result obtained in a test using a 25 millimeter cube sample at 140 degrees centigrade, but a positive result is obtained in a test using a 100 millimeter sample cube at 140 degrees centigrade, and one of the following. The unit volume of the chemical is more than 3 cubic meters, or a positive result is obtained in a test using 100 millimeter cube sample at 120 degrees centigrade, and the unit volume of the chemical is more than 450 liters, or a positive result is obtained in a test using 100 millimeter cube sample at 100 degrees centigrade. Classifying chemicals that are characterized as self-heating or spontaneous heating in nature is quite a scientific process. For most of you, how these categories are determined does not matter as much as the risk associated with the physical hazard category. The idea here, again, is to not get lost in the weeds, but rather have a very general understanding of how the categories are determined. That being said, let's now turn our attention to chemicals that emit flammable gases. Chemicals which, in contact with water, emit flammable gases are solid or liquid chemicals which, by interaction with water, are liable to become spontaneously flammable or to give off flammable gases in dangerous quantities. This classification of physical hazards has 3 categories: Category 1, Category 2, and Category 3. Category 1 chemicals are those chemicals that react vigorously with water at ambient temperatures and demonstrate generally a tendency for the gas produced to ignite spontaneously, or which reacts readily with water at ambient temperatures such that the rate of evolution of flammable gas is equal to or greater than 10 liters per kilogram of chemical over any 1 minute. Category 2 chemicals are those chemicals that react readily with water and ambient temperatures such that the maximum rate of evolution of flammable gas is equal to or greater than 20 liters per kilogram of chemical per hour, and which does not meet the criteria for Category 1. Category 3 chemicals are those chemicals that react slowly with water at ambient temperatures such that the maximum rate of evolution of flammable gas is equal to or greater than 1 liter per kilogram of chemical per hour, and which does not meet the criteria for Categories 1 and 2. Let's now turn our attention to oxidizing liquids. Oxidizing liquid means a liquid which, while in itself not necessarily combustible, may, generally by yielding oxygen, cause or contribute to the combustion of other material. There are 3 hazard categories listed under the physical hazard of oxidizing liquids, which are Categories 1, 2, and 3. Category 1 oxidizing liquids are defined as any chemical which, in the 1-to-1 mixture by massive chemical and cellulose tested, spontaneously ignites, or the mean pressure rise time of a 1-to-1 mixture by mass of chemical and cellulose is less than that of a 1-to-1 mixture by mass of 50% perchloric acid and cellulose. And in case you are unfamiliar with what cellulose is, I will elaborate. Cellulose is simply an organic compound found in numerous sources such as plants and wood. Category 2 oxidizing liquids are defined as any chemical which, in the 1-to-1 mixture by mass of chemical and cellulose tested, exhibits a mean pressure rise time less than or equal to the mean pressure rise time of a 1-to-1 mixture by mass of 40% aqueous sodium chlorate solution and cellulose, and the criteria for Category 1 are not met. Category 3 oxidizing liquids are defined as any chemical which, in the 1-to-1 mixture by mass of chemical and cellulose tested, exhibits a mean pressure rise time less than or equal to the mean pressure rise time of a 1-to-1 mixture by mass of 65% aqueous nitric acid and cellulose, and the criteria for Categories 1 and 2 are not met. Let's move on to oxidizing solids. Oxidizing solid means a solid which, while in itself is not necessarily combustible, may, generally by yielding oxygen, cause or contribute to the combustion of another material. Category 1 oxidizing solids are characterized as any chemical which, in the 4-to-1 or 1-to-1 sample to cellulose ratio by mass tested, exhibits a mean burning time less than the mean burning time of a 3-to-2 mixture by mass of potassium bromate and cellulose. Category 2 solids are characterized as any chemical which, in the 4-to-1 or 1-to-1 sample to cellulose ratio by mass tested, exhibits a mean burning time equal to or less than the mean burning time of a 2-to-3 mixture by mass of potassium bromate and cellulose, and the criteria for Category 1 are not met. Category 3 oxidizing solids are characterized as any chemical which, in the 4-to-1 or 1-to-1 sample to cellulose ratio by mass tested, exhibits a mean burning time equal to or less than the mean burning time of a 3-to-7 mixture by mass of potassium bromate and cellulose, and the criteria for Categories 1 and 2 are not met. Now that we understand oxidizing solids and their related physical hazard categories, let's move on to organic peroxides. Organic peroxide means a liquid or solid organic chemical which contains a bivalent structure and as such is considered a derivative of hydrogen peroxide, where one or both of the hydrogen atoms have been replaced by organic radicals. The term organic peroxide includes organic peroxide mixtures containing at least one organic peroxide. Organic peroxides are thermally unstable chemicals which may undergo exothermic self-accelerating decomposition. In addition, they may have one or more of the following properties: be liable to explosive decomposition, burn rapidly, be sensitive to impact or friction, react dangerously with other substances. Organic peroxides shall be classified in one of the 7 categories of types A to G for this class according to the following principles. Any organic peroxide which, as packaged, can detonate or deflagrate rapidly shall be defined as organic peroxide type A. Any organic peroxide possessing explosive properties and which, as packaged, neither detonates or deflagrates rapidly but is liable to undergo a thermal explosion in that package shall be defined as organic peroxide type B. Any organic peroxide possessing explosive properties when the chemical as packaged cannot detonate or deflagrate rapidly or undergo a thermal explosion shall be defined as organic peroxide type C. Any peroxide which in laboratory testing meets the following shall be defined as organic peroxide type D. Detonates partially, does not deflagrate rapidly, and shows no violent effect when heated under confinement, or does not detonate at all, deflagrates slowly, and shows no violent effect when heated under confinement, or does not detonate or deflagrate at all, and shows a medium effect when heated under confinement. Any organic peroxide which, in laboratory testing, neither detonates or deflagrates at all, and shows low or no effect when heated under confinement, shall be defined as organic peroxide type E. Any organic peroxide which, in laboratory testing, neither detonates in the cavitated state nor deflagrates at all, and shows only a low or no effect when heated under confinement, as well as low or no explosive power, shall be defined as organic peroxide type F. Any organic peroxide which, in laboratory testing, neither detonates in the cavitated state nor deflagrates at all, and shows no effect when heated under confinement nor any explosive power, provided that it is thermally stable, self-accelerating decomposition temperature is 60 degrees centigrade or higher for a 110-pound package, and for liquid mixtures having a boiling point of not less than 150 degrees centigrade is used for desensitization, shall be defined as organic peroxide type G. If the organic peroxide is not thermally stable or has a boiling point of less than 150 degrees centigrade, is used for desensitization, it shall be defined as organic peroxide type F. We will now discuss the final physical hazard under the Hazard Communication GHS standard, which includes chemicals corrosive to metals. A chemical which is corrosive to metals means a chemical which, by chemical action, will materially damage or even destroy metals. There is but a single category for chemicals that are corrosive to metal. Category 1 includes chemicals that have a corrosion rate on either steel or aluminum surfaces exceeding 6.25 millimeters per year at a test temperature of 55 degrees centigrade when tested on both materials. Let's conclude this video presentation with a summary. We have thoroughly discussed each of the 16 physical hazards associated with hazard communication GHS standards. Although much of the material discussed has pertained to various degrees of scientific methodology, it is important to keep in mind that most of you will not need to memorize this subject matter. Rather, I think it is important for you to understand the background on how the hazard categories pertain to each physical classification. I know that I have mentioned this numerous times, but it is imperative that each of you understand that the lower the hazard category is, the more dangerous to your health and physical environment the chemical can be. On another token, this video presentation has included the GHS pictograms on many of the slides in order to familiarize you with how the physical hazards and the hazard categories relate to the GHS pictograms. For example, chemicals that are considered corrosive to metals are likely also corrosive to human skin, and the appropriate pictogram denoting this hazard was presented. Remember, you can always go and look up the specific information we have discussed in this video presentation, and you do not need to memorize this material by any means. If you would like more information on any of the subject matter presented, feel free to contact me directly, as my information is listed on the screen. Have a great day, and thank you for watching this video presentation.